Namaste, Adab. Hope so all of you are doing well, especially my Muslim friends. Hope so they are doing well in this great month of Ramadan. Okay, let's start the session. In my previous lecture, in lecture number 2, I have given you a proper description about the JVM, JDK, and JRE, the definition, how they works, the differences between them. Hope so that all of you have understand that in this session, I'm going to teach you the four fundamentals of any object-oriented programming language. Let's dive into it. Okay, let's start the slideshow. Object-oriented programming in Java. Understanding, abstraction, encapsulation, inheritance, and polymorphism. These are those four fundamentals of any object-oriented programming language. Java is a fully object-oriented programming language based on four fundamental principles. Remember that four fundamental principles. Number one, encapsulation. Number two, inheritance, polymorphism, abstraction. These principles allow modular, reusable, and scalable code development. OOPs model real-world objects, making software design efficient and maintainable. Abstraction in Java. What is this abstraction? Okay, we will teach you this session. In this slide, abstraction is an object-oriented programming principle that hides the implementation details and only exposes essential features to the user. It allows developers to focus on what an object does rather than how it does it. A powerful way to manage the abstraction is through the use of hierarchical classification. Hierarchical classification or abstraction is a method of organizing complex system or information by breaking them down into progressively simpler, more manageable levels or layers. Examples of using hierarchical classifications or abstraction: computer programming. Object-oriented programming with its use of classes and inheritance is a prime example of hierarchical abstraction. System design. Suppose that you in your future you have get your dream job, and after 10 years of experience you have a role in system design, then you need this hierarchical abstraction a lot. Hierarchical abstraction is used in designing complex systems such as operating system, databases, communication networks. Human reasoning. Human naturally use hierarchical abstraction to organize their knowledge and solve problems. Architectural plan. An architect master's plan of building is an abstract representation designed to capture only the most essential features to get an idea of its overall makeup. Now, let me explain it with your real life. Suppose that you have a car. Okay, any it can be any kind of car. It doesn't matter. And what do you think the car of what do you think of your car? You just think of your car as a well-defined object with its own unique behavior. You don't know how this is made, how your engine works, what kind of elements are used in your engine. You just know how to drive it, how to drive it to the restaurant to eat food. You don't know the inner construction of your car. That is abstraction. Hiding the inner implementation of your code or anything is called abstraction. Right now, what is this hierarchical classification? Okay, suppose that um, you have a you can call anything a vehicle, like a car. It can be car, it can be a bike, it can be a scooty, it can be a school bus, it can be a truck, etc. In that super class of vehicle, there can be many subclasses like a car, a school bus, a scooty, a bike, anything else. And that car, you have different type of brands. That is the subclass of that car. And in each brand there are many models. That is also that subclass. It is called the hierarchical abstraction, hierarchical method, going top to bottom. Top to bottom. Okay. Key features of this abstraction: hides complexity. As I have told you that you don't know the inner implementation of your car, how the engine is made of, how the gear is made of, the accelerator is you can control it by just using your feet, but the inner complexity. You don't know anything about it. You don't need to know anything about it. That's the abstraction. Improves code maintainability. Changes in implementation do not affect the external code. Enhances security. Prevents direct access to implementation details because it hides the implementation details from the user. How abstraction is achieved in Java? Abstraction classes declared using the abstract keyword can have both abstract and non-abstract method. Contains only abstract methods, allows multiple inheritance. Okay, abstraction. Then see the code implementation. You just add an keyword abstract before any class or method, then that become the abstract. We will understand. We will see that in the future lectures. Encapsulation, data hiding. What is encapsulation? Encapsulation is data binding data and methods into single unit and class. I like a class. It restricts direct access to data members and will control access through getter and setter methods. It ensures data security and integrity by preventing unauthorized modifications. In key features, data hiding. Instance variables are declared private, meaning they cannot be accessed directly from outside the class. Okay. Controlled access. Get public getter and setter methods provide access to the data safely, improve code maintainability. Implementation details can be changed without affecting the outside code of encapsulation. Okay, let me tell you how it is done. Uh, Suppose that you have a box. Your whole code is wrapped. Sorry, sorry for this. Your whole code is wrapped inside this wrapper, and the data, everything is inside this wrapper. The functional methods, whatever you call, and that can change the data, that manipulates the data, it inside, only inside this wrapper. Suppose that you want to manipulate the data inside this wrapper from outside, you just cannot do it. It will not give you the access. This wrapper will not give you the access to do that. It prevents modification and manipulation from outside world to its data. Example of encapsulation in Java. Here it is. You can see by creating private. The private and public is just a access modifier. We will give we'll give more lectures about this access modifier. But right now I am telling you that when you create a variable double balance, this is the data type double, and this is the variable name balance. When you are creating a variable with private keyword, then you cannot access this variable outside of this class. Okay, but you can access this variable inside this class. You can modify it or anything, do anything else inside this class. But if you try to do anything with the variable outside of the class, suppose that you try to do something in this class with that variable, then it will prevent that. Okay, I hope so that you have understand. And this public, it suppose that you have created this variable public instead of private, then this variable can be accessed by outside world. This is how encapsulation is achieved in Java. Inheritance, code reusability. What is inheritance? Inheritance is the process where a new class acquires properties and behaviors of an existing class. You can relate it with your father. You have many basic or common things with your father or mother. This is the inheritance. Inheritance properties. It promotes code reusability and hierarchy based organization. The parent class is called the superclass. As I have told you in the beginning of the lecture, superclass. The child class is called the subclass. Types of inheritance in Java: single inheritance, multi-level inheritance, hierarchical inheritance. Multiple inheritance is not supported by Java, that's why it is in red mark. In single inheritance, one child inherits from one parent. Multi-level inheritance, a child inherits from another child class. Suppose that you have two sister or two brother, you have some common things with that. You just you you have a big brother, you just have some common things with your big brother, that is called child class. And that is called inheriting from another child class. Hierarchical inheritance, multiple child classes inherit from a single parent. Okay. Advantages of inheritance: code reusability, avoids redundancy and repetition, improve code structure, creates a hierarchical classification, is maintenance. Enhancement in the parent class automatically reflect in the child class. Now, what does this mean? That you don't need to create a method again and again. Suppose that your father has some feature, you have created that class for him, and you have the same features, you have the same common behaviors like your father. You don't need to put it inside your class. You just can inherit that from your father and along with your own behavior. That's how inheritance is achieved. Example of inheritance in Java. Okay. Suppose that here is the vehicles superclass, and this car is the subclass or child class of that superclass. As I have told you, vehicle can be any kind of. It can be car, school bus, scooty, or anything else. And inside this car, it has its own behaviors. And this car can also contain another subclass. This is called a child inherits from another child class, multi-level inheritance. This is called multi-level inheritance. If this if this Mustang, if we create another class for this Mustang, then it is called multi-level inheritance. But if there is nothing like Mustang class or anything, it is single inheritance. It is just the child class is just inheriting the properties of the superclass of parent class. This is done in on time. That's it is called, thus this is called single inheritance. Polymorphism, my favorite part. Method flexibility. What is polymorphism? Polymorphism is a Greek word which means many forms, that allows one interface to be used for a general class of actions. The method execution is determined at compile time, overloading or runtime, overriding, considering a function square which returns the square of a number. Now you can create a square method two times with the same name, but one for integer value, one for floating point value or decimal point value, you can say. By using polymorphism, you can write a class like this: compile time polymorphism. Okay, this is compile time polymorphism. This example, how see that I have created a class square. Inside that, I have created a static method called square with integer parameter. There is a difference between integer parameter and arguments. This is parameter, and whatever I will give inside, whenever I am calling this method and putting some value inside that method, that is called argument. Here a and b is argument, and here I is the parameter. Remember that thing. In interview it is asked, written I know that, I hope so that you know that how this square function is working. And see the second one: same name but different data type. This is for integer, this is for floating point, but the same name. Okay. uh, this is so much important. And now see that I have created a variable in my main method called a and b. A is the integer type variable and b is the floating point value variable. and in and here I am calling this two function with the same name, but the output would be different. Here I am calling this method, but here change the let me change the color. Here I am using this method. Okay, but if you want to do this in C or process oriented programming, what you need to do, you have to create two different methods like a square integer, a square floating point. That is a problem. You need to remember two methods, one for calling integer type values and one for calling floating point values. But this polymorphism reduces that. Types of polymorphism in Java: method overriding, same method name with different parameters, or compile time polymorphism. This is the compile time polymorphism. This is called method overloading. Remember that it is called method overloading. Again I am saying that, remember that this is compile time polymorphism and it is called method overloading. And and another polymorphism is same method name with different implementations in child classes. This is called runtime polymorphism. Let's see it. Okay, see here, I created a class called animal. Here I have created a method make sound. Any animal can make sound. Okay, child class overriding method. This is called runtime polymorphism. I am creating a class. Extends mean that it will inherit and every properties from this animal class, animal superclass. Thus, this dog is the subclass or child class, and animal is the parent class. And what I am doing with this, I am overriding the function that is being made inside animal class. Make sound. Animal makes sound. I am overriding that. And how I am overriding that? I am saying that a dog will barks. Okay. I am modifying, I am trying to modify this function inside my child class with its own behavior. But it has the behavior same. It can also make sound, but it has its own unique behavior. What unique behavior? Dog barks. That is how runtime polymorphism is achieved. Polymorphism, encapsulation, inheritance work together. Okay. When properly applied, polymorphism, encapsulation, and inheritance combine to produce a programming environment that supports the development of far more robust, scalable program than does the process-oriented model. As I have told that in C, it is not that much robust or scalable. When you create large problems in C, you will face many problems to maintain the code. Actually, in software industry, it is not all about creating a program. There is many other phases. You have to maintain that, you have to add new features. For those things, the complexity becomes greater and greater day by day. A well-designed hierarchy is classes if the basic of using the code in which we have invested time and effort developing and testing. And in the end, I just want to say that why you need to understand every concept clearly. um, you know that in the previous time you have to be ahead of other persons, but in this time you don't need to be ahead of other person, but you have to be ahead of the artificial intelligence. But how you think so that artificial intelligence is so much powerful, I cannot get ahead of him? No, not like that. You have a great feature in your brain which anybody cannot, anybody, anything else without human beings cannot achieve. Critical thinking. You have to be a critical thinker, you have to think deeply, and for to achieve that success, to achieve that skill, you need to understand, you need to understand every concept clearly. Without understanding the concepts clearly, you how you can think critically, how you can think deeply, how you can get ahead of the artificial intelligence. For that reason, I have launched this course so that you can learn everything from the deep. Hope so that you are enjoying the lectures. Okay, thank you. Thanks a lot for be with me. Hope so that your day will be good, and always learn. Try to learn every time. Don't settle. Just try to learn whatever you want to learn. That is my advice. Okay, thank you so much.